Assalamualaikum. My name is Muhammad Rizqal Sham, and today I will start this presentation by explaining to you guys about the objective of this experiment. First of all, the objective of this experiment is to understand the concept of centrifugal force. Second one is to investigate elements involved in the working concept of centrifugal force. And the last one is to analyze the data and to conclude the final result. So now, for the additional theory part, we found out two additional theory for this experiment, which is the first one is centrifugal force is a pseudo or fictitious force that is peculiar to a particle moving along a circular path. This force is of the same magnitude and dimensions as the force that maintains the particle on its circular path, but opposed in direction, which is the centripetal force. The second additional theory is centrifugal force is an imaginary force. It is also considered an important and reusable concept to understand and analyze the behavior of the fluid moving in a curved or circular motion. Now for the apparatus part. In this experiment, there are two equipment that involve, which is the first one is the centrifugal force and the second one is the weight. So as you can see on the screen, the first equipment is used as a base unit that contains a variable speed motor. Second, it also used act as controllable knob to adjust the speed of the motor. And the last function for this machine is it has liftable safety dome covering the motor while spinning. And the second equipment, which is the weights, function as the load that can be adjusted.
Now I will talk about of the procedure of fixed mass and radius vary speed. Firstly, we need to turn on all the power system and include a blank result table. If you are to use VDS, the software will automatically create the result table for you. So second, we need to lift off the safety dome. And then after we lift off the safety dome, we need to feed the 250-gram matching pair of masses with a total of 100 gram to the measurement arms at radius 100 millimeter from the center. And then after we feed the 50 gram, we need to feed a 100 gram single mass to the counterbalance arm at 100 millimeter from the center, opposite to balance the two opposite masses. After that, we need to feed the safety dome and then press the button to zero the force reading. After we press the button to zero, and then we need to turn the velocity control clockwise or anti-clockwise to set the speed to that shown in the first line of the table, and allow a few seconds for reading to stabilize and record the actual force. So for fixed speed and radius and varied mass, we need to create a blank result of VDAS software, and then we feed the two of 20 gram matching pair of masses to the measurement arms at radius of 100 millimeter from the center, and then feed a 40 gram single mass to the middle balance arm at 100 millimeter from the center to balance the two opposite masses. After that, feed the safety dome and press the button to zero the force reading. After that, turn the velocity control clockwise or anti-clockwise to set the speed to that shown in the first line of the table. Allow a few seconds for readings to stabilize and record the actual force. After that, we need to stop the rotation and repeat step from 4 to 7 with other matching weights as shown in the table 2. So for fixed speed and mass and a varied radius, we need to create a blend result table of VDS software, and then feed the 250 gram matching pair of masses to the outer balance arm at radius of 20 millimeter from the center, and then feed 100 gram single mass to the middle balance arm at 20 millimeter from the center, opposite to balance the two opposite masses. After we put the 100 gram single mass, we need to fit the safety dome. And then after we fit the safety dome, we need to press the button to zero the force reading and turn the velocity control clockwise or anti-clockwise to set the speed to that shown in the table. Allow a few seconds for reading to stabilize and record the actual force. After that, we need to stop the rotation and repeat step 4 to 7 with the other radius position as shown in the table 3. So
This is the result for the fixed mass and radius vary speed. Table 2 is the result for the fixed speed and radius varied mass. So this is the table 3, the result for the fixed speed and mass varied radius.
For the observation, there are the three components to this experiment. Past experiments have shown that the centrifugal force, which is in the direction of the real force, is influenced by speed, mass, and radius. First thing first, we can see that the force increases as the speed increases in the experiment, which is a constant mass, but with the varying with speed. Secondly, it has a variable mass but a fixed speed and radius. We can observe that the force increase with also the mass. And the third, we can see that the force increase as the radius increase in the experiment with a fixed speed and mass, but the variable radius is different. That's all for me.
Based on the graph of force against speed square, the graph shows a force is directly proportional to the speed square. The force increase and speed increase. This small deviation may be due to the parallax error. Based on the graph of the force against mass, the trend of graph shows a consistent increment and at the end it falls down. This shows that the force directly proportional to mass. This is because the misconduct during the experiment. The graph of the force against radius shows an increment in trend of the graph. Therefore, the force increasing linearly with the radius.
For the conclusion, the centrifugal force experiments suggest that changing the variable had substantial influence on the result. As the angular velocity, mass, or radius grew, the centrifugal force also increased. It was challenging to set up the angular velocity exactly, since they may be small, both change to the decimal point variance. The equipment could not have been calibrated to generate incorrect data. To prevent this mistake and acquire the test real valve, some factors must be taken into consideration before carefully regulating the speed. The researcher must first wait until the machine is in a stable state, and before performing the experiment, it's also necessary to test the machine to ensure it is operating correctly. That's all from me. Thank you.